Hi everyone. Today we're going to talk about rational functions. A rational function is a function of the form p of x divided by q of x, where p of x, the numerator, and q of x, the denominator, are polynomials, and q of x cannot be zero because we all know we can't divide by zero. We should always pay attention to the domain so we know what values the function can take and what values the function should avoid because they will make the function undefined. So to find the domain of a rational function, it means that we want to make sure that the denominator cannot be zero. So the denominator here is 2x squared plus 5x minus 12, and we don't want this to be zero. Just to make it a little bit easier to look at, to solve for this, I am going to get rid of that different from sign and change it to an equal sign. To solve this quadratic equation, we are going to use factoring. So the constant a is 2, b is 5, and c is negative 12 here. We want two numbers such that the product of two numbers equal a times c, which is 2 times negative 12, and that's negative 24. And at the same time, we want the sum of two numbers to be b, which is 5. So think about two numbers that multiply to negative 24 and add up to 5. The two numbers that satisfy both conditions are 8 and negative 3. 8 times negative 3 is negative 24, and 8 plus negative 3 is 5. So now we are going to rewrite the first term and the last term. And with the middle term 5x, we are going to change it to plus 8x plus 3 minus 3x, the two numbers we just found, and then factor by grouping from here. So GCF for this is 2x. That would be x plus 4 in here. And then GCF for the second group would be negative 3 and x plus 4. Factor again, we get x plus 4 times 2x minus 3. So we want all these to be equal to 0. And that means x plus 4 must be 0 or 2x minus 3 is 0. So x is equal to negative 4 or x is equal to 3 over 2. Now remember, our original goal though is we don't want the denominator to be 0. So you could easily change all these signs to different from. And so at the end, it means that the domain would be any numbers but negative 4 or 3 over 2. And if we were to write that in interval notation, it does help when you draw the number line, put negative 4 on there and 3/2 on there. And we're going to put open circle on both of them. And then we are accepting all the numbers but those two values. So we end up with three intervals. They are negative infinity to negative 4, and then negative 4 to 3/2. Notice that I'm using parentheses for all of them because we don't want to include those values. And then last interval is 3/2 to infinity. Now let's talk about some notation, and then we're going to investigate the behavior of a rational function. So if you see x and then arrow to c plus, that means x approaches the value c from the right. And then this second one here means x approaches the value c from the left. And in both cases, they will not equal to c. It will just get close to it, but never equal c. And then the next one is x approaches infinity, and then the last one is x approaches negative infinity. So here I have a graph of a rational function, and we're going to try to understand this graph, the behavior of this graph. First of all, the graph of this function only consists of the two blue curves. So this curve and this curve here. Okay, the black lines that you see are actually not part of the graph, but we are going to investigate those as well eventually. So part A, as x approaches negative infinity, so I want you to look for the part of the graph where x goes to negative infinity. We all know that on the x-axis, this direction is where x goes to negative infinity. So on the graph, on the blue graph, that would be this arrow right here where it's pointing to the left, because that's where x is going to negative infinity. So the question is, where would f of x go? So we all know that when you look at f of x, which is the same as y, we're looking at the vertical direction. So you got to think at that pink arrow, how does the graph move up or down? Now I see that the pink arrow gradually going down, very subtle. It's going down. So it looks almost like it's eventually go to negative infinity. However, it's actually approaching this black line right here, which is already marked on there. And that black line is, this is the value -2. So it looks like y is approaching the y value equal -2. So we're going to put -2 here. Okay, part B, as x approaches -3, and that minus sign at the top there, that means from the left. So x approaches -3 from the left. Okay, so first let's find where x equal -3 is. So that's going to be this value right here. That's where x is equal to -3. I'm going to erase it so it doesn't look too busy, but keep in mind that's where -3 is. So x approaches -3. Look for the curve where it's approaching that value. So that's going to be this arrow right here. Now, don't worry about the arrow going up right now. Because we're talking about x, we're only looking at the left and right direction. So even though it looks more like it's just going up, but very subtle, it looks like it's going to the right slightly. Because it's going to the right very slowly. And where is it going? It's actually going to the value -3. But it doesn't equal to -3. So remember, the notation is x would approach a c, in this case is 3, or -3, from the left, but it doesn't equal -3. Okay? So now they're asking, where does f of x go in that case? And now you can look at it as it's going up because we're talking about the y direction now. So going up means f of x goes to positive infinity. Or you just have to write infinity there. Okay, so let's move a little bit quicker this time. Part C, as x approaches -3 from the right, so that's going to be this arrow here. It's still approaching that value -3, and it's approaching from the right to the left. So where is f of x going? Looks like it's going down at the same time, so f of x is going to negative infinity. And then part D, as x approaches infinity, that's going to be this final arrow where x is going to the right. So it is approaching infinity. Where does y go? Well, it looks like it's slightly going up, and it's actually going up to that line where y is equal to -2. So it's approaching -2. Part E, the graph is increasing over what interval? So increasing means the graph must go up from left to right. So I'm going to highlight the section where the graph goes up, and that's going to be this one. Looks like it's going up from left to right. So with that interval, that's going to be, now we're looking at the interval for x. So it looks like it moving from left to right is going from -infinity, and then it actually doesn't go to positive infinity. It just goes to that vertical line where x is -3. So it goes from negative infinity to -3. And furthermore, the graph is also increasing in this section because, as you can see, it's still going up from left to right. So for that section, the interval would be -3 all the way to the right. So that's all the way to infinity. Okay, F, the graph is decreasing over the intervals. I don't see anything that goes down from left to right, so we're going to write none here. Now the domain. Domains mean anything that goes from left to right unless there's a disconnection in between, and there is. So there's going to be a disconnection here where this vertical line is. You see how the two curves are disconnected. So it actually never touches that vertical line, so it never equals -3. So the domain would be any real numbers but that -3. So we're going to write -infinity to -3 and union with -3 to infinity. Okay, the range is very similar, but this time we're looking from lowest to highest. So lowest, I see that is go down to infinity, and highest, I see that it goes up to positive infinity. However, there's a disconnection in between here where the curve would approach the line y equals -2, both in this direction here and in that direction, but they actually never touches that line y is equal to -2. So with that said, that means that the range could be any numbers but that -2. So we're going to write -infinity to -2 and then union with -2 to infinity. Now, part I and j will be talked about in another video when we talk about different types of asymptotes in a rational function.